This is section 4.3, and I am actually omitting page 125 in the Incredibles book. With these 2 pages, I am replacing one page with 2. We are skipping, or we have skipped pages 123 and 124 from section 4.2. If you're wondering what happened to those pages, I should have announced it in class if you haven't heard it, or if you don't remember hearing it. I have omitted sections from section 4.2, pages 123 and 124. So now we're doing page 125, but I'm replacing that one as well. Alright, so in the previous section, we talked about left endpoint rectangles, right? Finding the area under a curve, approximating with left endpoint rectangles or right endpoint rectangles. Now, there are other ways to do it, and in this section, we're going to study 2 other ways to do it. All right, or 3 other ways. 2 are related. The third way is something else completely. All right, so what we're looking at here is a 1998 AP Calculus free response question. So this is the graph, this is the table of the data. All right. So the graph is velocity, okay, of a car traveling on a straight road from 0 to 50. Table of values at 5-second intervals is shown here. Right? Now we're going to approximate, and up to this point, or maybe not, I'm not sure, whether you have been shown that this is the same as something called a Riemann sum. Now up to this point we did left endpoint, right endpoint. We might have done upper sum, lower sum. Now what we're doing is something called midpoints. We're doing midpoints of 5 subintervals. Then you might be like, well, that's a lot. Well, that looks like more than 5. Well, it is more than 5, but I'm using midpoints. Since I'm using midpoints, that's one interval. That's another interval. And 3, 4, 5. So in fact, they gave us enough points so that we can use 5 subintervals. Okay. At this point in time, we're not going to be worrying about using the correct units and explaining the meaning of this integral. The point of this exercise right now is just to show you how to do midpoint approximation. We're using midpoints instead of left endpoint or right endpoint. We are now using midpoints. Okay, just a reminder what left endpoints would be. Left endpoints would mean that I will use this endpoint of, if I'm using the same 5 subintervals, right? So I'm skipping these, so I'm using 5 subintervals. If I were to use left endpoints, I would use the 0, make the height of the first rectangle, and then 10 to make the height of the second rectangle, and then 20 to make the height of the third rectangle, and so on and so forth. If I were using the right endpoint, I would use 10 to make the height of the right rectangle, so that would be this, and then 20, right, for the second one, and then 30 for the third one. Okay, but now I'm using midpoint. So now the midpoint version is only possible when these units are uniform. Okay, so that's actually kind of rare. All right, but if they do make them uniform, that means they want you to use the midpoint. Okay, so here each unit, each subinterval is 10 units wide. Each subinterval is 10 units wide, and the midpoint is at the 5. So here the midpoint is at 5, 15, 25, 35, and 45. Alright, so here's what we're going to do. So each subinterval is 10 units wide, so it's 10. Alright, I'm doing base times height, and then the height is going to be determined by the 5, or the midpoint of that subinterval. And we have this table to tell us the exact value, so you don't have to guess what it is. So the height of the first rectangle is 12 units. Right? Each subinterval is 10 units, and the height of the first one is at the 5-second time, and it's 12 units high. Plus, now I'm going to do 10 times the next one, which is 30. Right? The midpoint of the next subinterval is 15, so the height is 30. Right? So here, the subinterval is 10 to 20, the midpoint of that is 15, and the height is 30. Do it again. 10 times, next in subinterval, the midpoint is 25, the midpoint is 25, and the height is up here. It looks right on 70. Let's check over here on the table. It's 70. And then next subinterval is at 35. Or did we just do 30? No, 35 is here. So it's up here around 80, probably 81. Okay, 81 plus 10 times. And the last subinterval, 40 to 50, 40 to 50, the midpoint is 45, and it's 70, no, it's 60. All right, so that's it, and we add it all up. I'm going to go ahead and take out the 10, and we're going to just add 12 plus 30 plus 70 plus 81 plus 60. All right, so I'm just going to use a calculator if I could find one. Okay. Alright, so that's 12 plus 30 plus 70 plus 81 plus 60 makes for 1253 times 10, so it's 2,530 square units. Alright, that is it. That is that example. Alright, that's using the midpoint technique. Alright, and I'm going to do at least one more using midpoint. Here's another question taken from free response, past. Oh, I forgot to put which year. Alright, so here's a similar chart, and notice their uniform width. That's a warning sign letting you know they're going to ask for midpoint. Alright, using correct units, explain the meaning of that. We're not going to do that part. We're not going to do the explaining part. We're just going to use a midpoint Riemann sum with 3 subintervals going from 10 to 70. 10 to 70. So we're only going from 10 to 70. So 3 subintervals. That's 1, 2, 3. Those are my 3 subintervals. Okay, of equal width. So midpoints, they're going to come out equal width. Okay. I'm not sure if you've been given much experience with unequal widths at this point. I don't think you have. So this is not a surprise to you. All right. And we're going to use the midpoint. So the midpoints are 20, 40, and 60. Okay. All right. And what's the width of each subinterval? The width is 20, 20, 20. Just double checking. All right. And so it's 20 times the height. The height is the v of t, so it's 29 plus 20 times the midpoint height is 40 plus 20 times, and the midpoint height, wait, did I do that right? I did not do that right. Okay. In fact, I did them all wrong. So it's 20. I actually marked it and didn't use it. Sorry. So it's 22 plus 35 plus 44. Alright, so I marked the midpoints and then proceeded to not use them. So sorry about that. So if you got confused. Alright, so these are the midpoint values. Right? Between 10 and 20, between the first subinterval, the midpoint occurs at t equals 20. In the second subinterval, the midpoint occurs at t equals 40. And in the third subinterval, the midpoint occurs at t equals 60. But you got to look at the y value, the v of t value. So there, it's 20 times 22, because the subinterval width is 20. That's where that 20 comes from. The height is 22. And then I go 20 more, and the height is at 35. And go 20 more, and the height is at 44. Add that up, and that's your answer. So it's going to be 20 times 22 plus 35 plus 44. By the way, if you notice that this pattern is almost the same every time, and you want to do this, in other words, I'm saying, if you think this is the pattern every time, and you want to skip to this step, don't do that. I notice. This uniform width only happens with midpoints. Okay, almost always only happens with midpoints. Sometimes it happens with trapezoids, but don't count on it. So don't count on uniform width. So don't get in the habit of going straight to this step. Don't do that. I'm not saying it doesn't happen. I'm just saying it only happens about half the time, and maybe you get the one test where it never happens. It's better to go ahead and write it this way so you don't fall into the trap of thinking they're always going to have uniform width. Alright, so anyway, now let's do that one. And I'll just calculate it, and it's just 2020. Oh, God. Sorry. Okay, so it's 20/20, and that's the answer there. All right, so that's the last midpoint example. Hopefully that's enough for you to understand. Let's move on to trapezoids. Okay, there is a trapezoid formula, and we will look at that, but it's actually kind of rare for them to actually ask you to use the formula, but that doesn't mean it won't happen, and it's not that big of a problem. It's not that big of a stretch. Not like the other things I skipped. Right, so we're going to do trapezoids now. So this is another way to approximate the area under the curve using trapezoids. If you recall, the area of a trapezoid, we'll do that here, is 1/2 the height times the sum of the two bases. Okay, and the way we're going to be drawing these trapezoids is actually on page 126, and I'm going to flash that up here. So the trapezoids will look like this. So our height is going to be the width of the subinterval, and our two bases are going to be like the left endpoint height and the right endpoint height. Okay, and that's going to be our trapezoid. So our trapezoids will be drawn vertically instead of sideways like a normal trapezoid. All right. All right. So here, use trapezoids to approximate the end of the curve using 4 subintervals. So the 4 subintervals. So we're going to be 1/2, 1, and then 3/2. So that's how we're going to split up our interval from 0 to 2. We're going to have 0 to 1/2, 1/2 to 1, 1 to 3/2, and 3/2 to 2. So that's 4 subintervals. 1, 2, 3, 4. Sorry, excuse me. You're going to wish I edited that out. Too bad. All right. Oh, yes. Okay. F of x equals x squared. That's our graph. So we're going to stop there, and we're going to begin here. Okay. So each subinterval here is 1/2 unit wide, and the left endpoint here is 0. Right? I'm plugging in 0 and getting 0 for y, so it's 0. I'm plugging in 1/2 and getting 1/4 plus 1/2 times, now I'm using the left endpoint, which is the 1/2, so it's 1/4 again, plus the right endpoint, which is 1. 1 squared is 1, plus 1/2. Remember, each subinterval is 1/2 unit wide. So we've done the first subinterval, second subinterval, now we're in the third subinterval. So the left endpoint of the third subinterval is at 1, so it's 1 squared is 1. And then 3/2 squared, which is 9/4, okay, plus 1/2, 9/4 again, right? So the last subinterval we're using, the left endpoint is at 3/2, okay, so that's where the 9/4 comes from, and then plus 2 squared is 4. All right, what I want you to notice here is that the far left endpoint is used once, the far right endpoint is used once, and everything in between is used twice. Okay, that's a pattern I want you to recognize. Now I'm going to take out the 1/2. So it's going to be 0 plus, there's 2 of those, there's 2 1/4s, and there's 2 1s, and then there's 2 9/4, and 1 of the last. Okay, of course you do not need to work it out this way. You could just throw it on the calculator, just add it all up. Okay. However, what I want you to notice is this pattern, and that's what's going to where the formula for trapezoidal sum is going to come from. Okay, there's an actual formula, right? Where the left endpoint is used once, the right endpoint is used once, and all the endpoints in between are used twice. Okay, now we're going to work this out and get an approximation. And what do we got here? 0 plus 0.5 plus 2 plus 9/2 is 4.5 plus 4. Okay, and I'm getting 11, which means it's 5.5. So that's our approximation. Okay, now up to this point, you're probably wondering, how are all these related, right? What I mean is, how is the left endpoint, the right endpoint, the midpoint, the trapezoid, how are they all related? Okay, so as it turns out, the left endpoint approximation and the right endpoint approximation, if you average those two, you get the trapezoid version. Okay, so trapezoid is actually the average of the two the left endpoint and the right endpoint. It is not the midpoint. Midpoint is not the average of left endpoint, right endpoint. So don't fall into the trap, because it seems like because you're taking the middle that the midpoint will be the average, but it is not. Okay, it is trapezoid that it turns out being the average of the left endpoint and right endpoint. Okay, that relationship is not particularly important, just to point it out. Okay, all right, going on to we'll stop there, and so you can take a break.